Okay, well, there was some other, we talked about some big news right at the top.
Earlier, yep.
There was some other really big news this month, middle of November exact, and you can be excused if you didn't catch it. Although, this news actually affects every single person on the planet.
Whether you
I think,
know
or
it or
pretty
not.
much, whether you know it or not,
Yep.
one way or another, it affects you. And the big news is delegates representing countries, 60 countries, 58, 60 countries, voted last month in Versailles, France, to implement the most significant change to the International System of Units, the SI, in more than 130 years. For the first time, all measurement units, this is the big news, listen, all measurement units will be defined by natural phenomena rather than by physical artifacts.
Do you hear that?
Right? It's great news, right? All of you? Come on.
Crickets.
Anybody? Bueller?
This is important news.
This is important news. This is really important news, particularly in our industry. The event was the 26th General Conference of Weights and Measures and was hosted by the International Bureau of Weights and Measures in France. They're the ones who kind of oversee everything related to weights and measures.
Ever since the meter convention.
Ever since
right?
the meter
Back in
convention, 130 years ago. And the big part of the announcement was that soon all measurement units, weight, length, time, temperature, what have you, you will be based on physical constants. Now, as most of you know, it used to be, it's been quite a while, but it used to be all standards, all measurement standards were based on actual physical things. So there was a meter standard, and it was a standard, a physical thing that existed, and this was the meter standard upon which all other meters in the entire world were based on. There was a time standard, there was a weight standard, we'll get to that in a little bit. There was a physical standard for everything. Over time, we were able to kind of base those on physical constants. So for instance, the meter is no longer based on the meter, it's based on light. It's based on the distance light travels in a period of time, right? And what else? The time. The second is based on the cesium atom, the oscillations in a cesium atom. So many oscillations, billions of oscillations, exactly equals 1 second. Okay, so based on physical constants that never change. Well, the holdout has been the kilogram. For 130 years, the kilogram was defined as the mass of a specific physical object, a shiny metal cylinder pucky kind of thing that since 1889 has been stored in a vault on the outskirts of Paris. But now the kilogram also will be based on a physical constant. It's going to be based in part on Planck's constant, and part of the vote of the 60 delegates last month was to actually set Planck's constant to a specific value. They finally had to decide, okay, how many decimal places and what is this thing going to be? So Planck's, and I won't read it here, there's actually 6-point change plus times 10 to the minus 34th meters squared kilograms per second or something like that.
Wow.
That is actually what Planck's constant is, and they all have agreed, okay, that is now going to be Planck's constant. And from this fixed value, scientists can derive the mass of a kilogram. So you're asking, how do they do that? Well, I wish I could explain it really well, but I'll give it a try. It goes something like this. Deep in the bowels of NIST's laboratory in Gaithersburg, Maryland, is something called the Kibble balance, or Watt balance. Yeah,
there it is.
That was really good timing.
That's great.
It's a very strange looking thing. It looks like a steampunk thing. And what this does is it equates the mechanical energy exerted by the mass of an object, the thing being measured, with an equivalent amount of electrical energy. So it equates mass, the unknown, and velocity, gravitational pull, magnetism, and electricity, all of which were based on physical constants. So there's 2 steps in this thing, the way this thing works. And I hope I'll get this somewhere in the ballpark of being right. First of all, there's a weighing mode, and that's exactly what it sounds like. A test mass, kilogram for instance, is placed on a pan that is attached to a coil that within a magnetic field. And it exerts, the mass exerts a downward force, gravity, and the current is applied to the coil and adjusted until the upward force, like electromagnet, right, is precisely equal to the balance of the downward force. So you got this mass coming down, and you got this electromagnetic force pushing it up, and when it's exactly equal, they measure the current that is recorded in order to keep that magnetic field at the point where it equalizes the mass. Okay, so that's the first part of it, and they measure that current. But there's some steps I'm leaving out here now. But this also needs to be calibrated. So there's a second step in this process, in which the coil that we're talking about is moved through the surrounding magnetic field at a carefully controlled velocity, and the resulting induced voltage is measured, and then all that data is plugged into an equation, and voila, you have the mass of that thing. Okay, so the thing is, all these other measurements, gravitational force, velocity, current, etc., are all based on physical constants as well. So the entire process is done utilizing physical constants in order to determine a mass, which of course then itself is going to be based on physical constants. So now we no longer have the need for Legrand K, it was called. It becomes kind of a doorstop now. We don't need it anymore because we now have a way to determine precisely what a kilogram is using physical constants. And it's much more accurate than having, even though this was pretty accurate and maintained its accuracy pretty well, it was constantly losing mass for various reasons because it's a physical thing. It's not going to stay the same forever, right?
Exactly.
But physical constants never change. So if you can base mass on physical constants, which what the Watt balance allows them to do, now you have something that is should never change. And the only thing you can do is improve the accuracy with which you're taking these measurements. So obviously, every time you're making a measurement, whether it's current or gravitational force and all that, you still need the accuracy in doing those things, and the equipment needs to get more or less accurate. Will get more or less accurate, more accurate. But you're still measuring physical constants. You're not measuring a hockey puck. Right. So the resolution will take effect on May 20th, 2019, and at that point, along with a few other resolutions, all measurements will be based on physical constants. So no more artifacts. There we go.
That's really cool. Good
It's
job,
pretty cool.
You did
pretty
a great
cool,
job explaining that.
Yeah, I don't know if it was accurate, but it sounded really good.
No, it sounded great. I mean, but this has been something they've been working on for quite some time.
For a long time, yeah.
And I mean, this idea.
And the Watt balance has actually been around for a long time,
while,
but it was getting more and more accurate. So.
But it's interesting because I mean, this has been a known issue for quite a number of years, decades, and that I think that scientists were groping for a better way to do this for quite some time, and this is a much better solution because again, it's you wouldn't think that an iron bar, or whatever iron,
iridium, palladium, something like that. Yeah.
But I mean, you say like, well, that's not going to degrade. It does degrade to
Platinum
a very tiny, imperceptible degree to the human,
Yeah. Well, I think I read somewhere that it is lost about 50 micrograms of weight, or is varied 50 micrograms,
which essentially nothing. But I mean,
well, it used to be essentially nothing, and the problem is more and more they're needing more and more accuracy. So they need 50 micrograms is too big anymore.
That's right.
Too much of an error.
It's really interesting. So good stuff there.